All right, guys, I'm Nicolette, and today Brian and I are here with Ahmad Malkawi. He is the CEO of Global Telecom, and he's going to talk with us today a little bit about wireless, module security. We're going to get really deep into the technology. So thank you so much, Ahmad, for joining us today. We appreciate your time.
Thank you so much, Nicole and Brian. Thank you for allowing me and giving me the time to talk to you guys. This is great. I appreciate that.
Awesome. So why don't you kick us off by telling us a little bit about yourself and your background and your journey to Global Telecom. I do understand that Global Telecom is one of, I think it's the only U.S. company for wireless modules. So tell us a little bit about that as well.
Sure. Thank you so much. Well, I always tell my wife, I'm so happy that I make money what I do because I grew up, the only thing that I do is physics and math and engineering. I grew up in a family of 11 children, in which 6 of us were engineers. And I was the youngest boy, so you could imagine growing up and where the bar was set so high. It's really interesting. I remember in high school, I finished high school early. I finished when I was 16, but I had a brother already finished when he was 14. And
you underachiever.
All right, a lot of one-upping each other, I guess, huh?
I supposedly it was the 99th percentile, but I was in tears when I got the scores. And this is a high school score where there is a suicidal rate. So this is really tough, decides your life. But anyways, now I'm thinking about it, like I wish I go back and I could celebrate. Really, I've done it that time. Then I came to the U.S. when I was about 16. I went to school, university, and I've done very well. But that's all what I knew. That's all what I do is engineering. And and I remember I took a communication class. I think I dropped it because I just didn't know what to do there. There's no numbers, no so. But luckily, I finished my university, and my first job was with AT&T Bell Labs back in 1994. And since then, it's just like you're in space. You just see the whole world in a greater lens, where you see everything is just bright. The technology and all of the things that you could do and what you do. And I work with Qualcomm, with Motorola, with T-Mobile. I enjoy every minute of what I've done and what I do every day. It's and then it led all of that, obviously about 15, 16 years after all of this technology, immersement with different companies, I've decided to do something on my own. To say that there are a few things I would like to bring to the world. And one of the things that we focused on is exactly what you said, Nicole, is there is this called heart and brain in every device, cellular device or modem, which is called the module. And I've realized there is really no US-based modules. And from what I'm thinking is like security-wise, like, if anyone could get to that module, we're toast because everything we have, whether it's a cell phone or a pad or a car now, all of the cars have, modules. Your blender at home communicates. Imagine waking up at night and your blender going crazy. I mean, that's real. This is real.
Yeah.
We just get a bed, and the bed is keeping track with all of the information, sleeping habits, everything we have today, literally connected. And this is really the Internet of Things. This is when a lot of people when say Internet is literally everything. It should be called Internet of Everything. And it's a great feeling to be in that kind of ecosystem, and it's supposed to help us out. But at the end of the day, we have to approach it carefully. Is how do we really make sure that this is a tool that works for us, not works against us? And that's really the whole idea of creation of Global Telecom in this field.
So when you say a module, right? You're the wireless module. What components does that consist of, right? So what's in the module?
So the module really consists of the basic chipset that holds the protocol, like the LTE or 5G. It holds all of the out of fronts, holds all of the memory, all of the computing that actually goes into the device to make connection with the network. So it's really a mini PC with antennas. That's really what a module is. And that is, think about it. Let's say if you have a router at home, the router does the Wi-Fi and does all of that stuff for you. But inside the router, let's say the cellular, there is that module that actually makes the link between the internet, the world, and your Wi-Fi and what have you. And it's the same for everything. So even if your car, let's say if it's doing communication with the network, that module has everything it needs to make the communication.
Mm-hmm.
And that's why we call the heart and brain of the system is right there. That's really where everything almost resides. Everything goes through. Without the module, you won't be able to communicate. And now we're doing the standardized modules, where basically you could make one module and you could plug it into thousands of different devices. Because the interface and all of that, we standardize that. There is no change or no variety. That's, if that makes sense, that's really what the module is.
So where does your antenna design come into play? I believe it was an antenna design that many devices are centered around, right? This mitigates the interference. I read a little bit about this. So where does that come in?
So that's the antennas are in my opinion, at least because I came from antenna design, I believe is the most crucial part of any system. And it's really like your eyes. And this is by all means. So if you really have any issues with your eyes, short-sighted or far-sighted, your vision is, basically not right. So the antennas are sensitive in the sense that the placement of antennas, the gain, and all of that. There's about more than 50 different parameters that play that you could increase your performance or decrease it or be susceptible to interference. Your throughput, which is everybody's, like speed and latency. You need like fast and like the gamers or us. That's all dictated by how you structure your antennas around your system. I'll give you an example. I don't know if you guys could see this. This is one of our devices that we make. And this is almost twice the size of a typical device like this. This is called the USB dongle. And I remember a story when we were told this by T-Mobile about a few years ago. They said, they want us to build the same exact device like what they had before. And when a big company comes to you and say, I wanted to build something, usually you say, yes, sir. So at that moment, I said, we're not going to build this device. You could find somebody else. And I knew the people. It's like, well, why do you say that? I said, if I build you the same device you're used to, we will not sell a lot. We'll spend a lot of R&D and work and a lot of returns because the device will be taken to a home or business, won't work, and bring it back. But I will build you similar device, but the device I'll build you, it will work. So after days of debate, they said, okay, just build the device that you think. Now, this device is the only approved device for government contracts because of the performance. So exactly what we just said. We said it's actually about 3 dB higher, which is double the power. 3 dB in our world is when you do it, that's double. So now it's about 3 to 4 dB higher than any equivalent. That's and it's all antennas. This is pure antenna design. The size of the antennas, the feeding, the performance. And then gets a little more tricky. I don't know if you could see in the back of my window, we have a small black box. That's a device we built that has 8 antennas, not 2 or that actually, and again, that's 12 dB. That's 100 times more powerful than equivalent. And we believe and this applies for not just cellular, for any system in the world. If you truly want to have that, performance and not, you have to design obviously all of your system well, but antennas are crucial. And how to place them, how to, of course, one of the tricks is the cost too. I mean, you could build a big system, cost $100 million. Nobody could afford that. But to build a system that's, let's say, under $200 and be able to actually do that, that's very tricky to do that. And this is one of the things we pride ourselves in doing, is actually be able to do that.
What do you think, we're talking to design engineers here. I mean, what do you think they should know about this? Is there something that they're, commonly challenged with, or something that maybe they're not, well, I don't want to generalize, not doing right, but maybe something that they should know about, this type of design as well?
I believe so. I believe antenna design, especially for radio frequency engineers and for engineers in general, it should be, in the education level, should be in the curriculum. And I did that. I actually took engineering, radio frequency and propagation in my undergrad. And it was a rare course in my university, a new course, and I liked it. It was great. I don't know if they still teach it, honestly, or not. But I really believe they should incorporate that in education. And the industry, once you go in the industry, they should have training. And I mean real training of at least the basics of antennas. And that will take us a long way of being efficient, having things that work. And you know that. Sometimes your cell phone doesn't work. Sometimes you have a hotspot doesn't work. And a lot of times we call it black magic. It's really not black magic. It's just something we don't know. We should, it's just a little bit of knowledge will take you a long way. And this is something I focused on. I remember during AT&T and Bell Labs time where I just didn't believe in this something called black magic. There has to be a cause, a scientific cause. Just because I don't know it. You know, like now they call it dark matter and black matter. It's really just we don't know it. You know, it's like once we know it, it becomes something else. So it's really as much knowledge as we can behind it. And there is nothing wrong with saying there's things I don't know. But there are things I think we could really follow, like interference, for instance. You could have some of the strongest signals you could have, and your throughput is so low. The first thing you look is your carrier over interference, C over I, and that's crucial. You could have very weak signal if your C over I is good, then actually your throughput goes up. And now we're building our AI algorithms in our devices to pick your best performance based on these parameters, your C over I, your modulation, all of that. So it's really not just about signal. You know, say it's like when you do I don't like to, but let's say if you're in a fight, or let's say if you are playing football, you can't put all of your in offense. You know, you can't just leave your back unprotected, right? So you have to have balance. And this is really how it is between signal and interference. You cannot just have too much power and leave your back behind where interference is susceptible, which is an interesting concept because the more power you transmit, the more interference you cause. So you are actually causing interference to the ecosystem. So the ideal way is to transmit enough power, not too much or not too low, just to what you need it. And that's engineering. That's really, you know, the basics of engineering is, you know, you can't overdo it or underdo it. You're just going to do it right. And those basics, we have to really go back to the almost education level for training and education on.
So you mentioned AI in there, right? Are you saying I want to make sure I understand. So the AI is built into the module that actually is saying like, okay, here, I'm going to up the power. I'm going to decrease the power depending on how my connection is.
So we have limited, what are called limited parameters that we can use with AI. So we have to comply with LTE and 5G protocol.
Right.
But within these, and this is again another tricky part, within these parameters, we have some luxury to actually make some changes in our model, and that's instantaneously. This is not something, this is actually near life, where the device will do its best to select, and I'll give you an example for that. If I am sitting here, I may be surrounded by 3 or 4 towers by, let's say, AT&T, Verizon, or T-Mobile. Well, that's typical, especially in urban areas. And sometimes the closest tower that gives you the best signal may be congested or overloaded. So in reality, if you do like a quick test and you connect to 4 different towers manually, you probably your best throughput or your best performance is not your closest tower. Right. And this is not like, this is typical. This is actually not like a rare incident. It's just because the way the RF works. Now, if I am sitting here and my device has the ability to find which is my best performance towers that I could connect to, ideally, I would connect to that tower, especially if I'm looking at throughput, because throughput is, or data is a lot more than voice. Voice doesn't need a lot of data to actually connect. So with voice, you could probably still okay. But for data, for browsing, for all of that, in many cases, your best bet is not your closest tower, which is the network dictates. Our system is working around that area, is to actually find out what is my optimum connection rather than my closest connection or my best signal. It could be a combination of best signal, C over I, and capacity resources, you know, available. We're trying to do the device. Ideally, that should be part of the protocol. Ideally, I would expect 5G and 6G to actually go in that direction and to give indicators to the device that you probably should be connected to this one rather than this one based on certain parameters. But I don't think they're there yet. So we're building that internally in our system.
Yeah. So do you think with 5G like being rolled out, right, you're going to see more and more of an increase in sort of that smartness to the connections?
I don't know if 5G will get that. It's probably going to be more like 6G. That's what I would think, which is built more intelligence in the devices, you know, rather than just the network.
Gotcha.
The devices has quite a bit of intelligence now, and the processors are very, very powerful and very fast. In the old days, I understand we didn't have that much capacity or power to actually do that. But now, the newer devices, your iPhone processor is as fast as your Apple Mac. So we don't have a problem with that. So the device intelligence can be quite powerful and very important even for the network. I mean, if you think about the network, if I have a tower and it's congested, the last thing I want to do is add more things to it. I would rather to breathe out, distribute my resources, right? So it's really, we're almost doing a favor for network providers by actually connecting to the least congested tower or element at that moment. And I expect that to be like what I said in the next protocols coming through.
Now, you mentioned some companies that you work with already. Can you give us some examples of how you assist these companies when they come to you? Are there some typical asks they have?
Yes, I mean, we work with very close partners, and usually it's around, I'll give you an example. They usually throw like big tasks on us or hard tasks because they know the engineering background that we can do. I'll give you an example of Chromebook, for instance. Chromebook 2015 abandoned the broadband connection because of security, and that's very important. Chromebook has a high level of security. They found out that the modems they insert or the modules they insert in the Chromebook actually brings the security. That's their bottleneck. Because once you're in the CPU, then you will have access to the Chromebook, and you might actually even have a piggyback to the network. So 2015, they actually abandoned the broadband connections. In 2016, I was approached by some colleagues from Sprint at that time. Excuse me. And they asked if we have a way around that because they believe the future for, and we did. The way we did it, actually, although we put a module inside the Chromebook, but the interface between Chromebook and the module is called native language. So it's something Chromebook understands. So let's say if the module is compromised, hypothetically speaking, Chromebook doesn't need to be compromised because they're actually virtually separated. And because of that, and we created something called hostless device. And this is all of our new modules are based on that. The hostless device means you do not need the host to contribute to your connection. So you establish the connection 100% on your resources. So all of the components we inserted in the module are enough to do the connection. Based on that, we succeeded. Chromebook was relaunched in 2018 with the same idea that we proposed to Google at that time to actually relaunch it with called hostless module. So this is the type of kind of relationship. We have close relationship with our partners. We're working with T-Mobile, Verizon, and the big companies right now to provide modules today. But again, we're new in the race, so we're still smaller at growth, and we're hoping for the best. We're like I said, you're the only module manufacturer in the U.S. Would like to expand on that.
Now, do you see this? So you mentioned all this hostless, all these hostless modules are being built into everything. So are those now also, besides things like Chromebook, are those also being used in mobile devices like phones also?
Well, sure. The phones have modules as well, but the phones, it depends on who's the manufacturer. They tend to keep it close to their chest, so they build their own modules.
Right.
But the answer is yes. All phones, all tablets, they would have a module type. Now, who's the manufacturer will depend on that relationship.
Right.
Well, I want to touch on the security aspect again, because this is where the hostess came up. But there's something that I read about quantum cryptography. What is that? Can you explain that? Because Brian and I were talking about this before. We're like, what is that?
It's a very interesting topic. I mean, when I even think about it, I just go excited because it's physics. I love physics, and so quantum cryptography really is essential for quantum computing. Quantum computing is around the corner, and when I mean corner, I would say in the next 5 years, we probably will see some sort of quantum computing around. And just to understand what quantum computing is in general, it's the greatest tool probably mankind has ever built, and is the scariest tool that mankind has ever built. Because and we always give this example to solve a factorial problem of 1200. If you have a 1200 factorial, for some of the fastest computers today we have, it will take near 10 billion years to solve it,
Mhm.
literally, with a size of 25% covering this Earth, which is basically impossible. Quantum computer can solve that problem under 10 minutes with a size in your palm. So this is just gives you an idea of the computing, which this really means all of the security, all of the encryptions we have in the world today, that can probably solved in minutes with a quantum computer. This is, like I said, it's great computing power, but it's scary as well. I'm sorry for this. So for quantum cryptography, basically you have to fight, call it iron with iron. And the only way you could really slow down or have the quantum computing not able is produce a quantum cryptography based on the same concept, which is based on photons and based on physics rather than math. Mathematical security, no matter how powerful it is predictable math. So you just need big enough computer to find out what's your key. Physics-based or photon-based, it's unpredictable because the photon, it could behave as a wave or a particle unpredictably. That's based on entropy. And because of that, we can create keys based on the quantum cryptography. And the key for that, what is the reason for that, is it's called the true randomness, quantum random number generator, QRNG. If we can create a key that you cannot predict because it keeps changing, then even quantum computer cannot predict it because it doesn't matter how long it will take, they will never have the same key repeat again.
Right.
That's what we're doing. Now, in theory, it's big and all of that, but it's in practicality, we're about 4 quarters probably from having one of the first products to demonstrate this. And the key for that is, again, you have to make it small enough, cheap enough to put it on cell phones or make it small things. Now you could make it expensive, but we're trying to packagize it to make it so small and practical for the IoT things.
So, I mean, that almost makes it completely secure. Like there's no way anything is ever getting in. Now, do you see that impacting other things like, in terms of like anything that's crypto, let's say, like even like cryptocurrency or how people store money or how people are doing banking or any secure transaction? Do you see it being applied to all of that?
100%. Any client, any device out there, if you equip it with QRNG generator, which is basically based on quantum, it will produce that level of security. Now there is more to it. Quantum computers are fast. We need to be even trickier. Instead of having one LED, we'll put 100 LEDs, and it's all macro and all of that. So I wouldn't say it's game done. It is work in progress, but we're producing something called quantum resilient and eventually quantum proof. But it is something we could truly fight back if we have to, hopefully. But I mean, if you think about just the fight back, I mean, in 2020 alone, we have 17 major hacks. In 2020, we had more than 80 hacks. So there are people going after us. This is not, so because of that, and they have limited resources today in a way. But imagine if they have quantum resources. Then multiply this by 100 or 1,000. There is nothing secure. They will find everything. Right. So we definitely need to be prepared to do that level of computing.
I understand. I was going to ask actually what types of why it can be so scary, and I understand now the flip side of that. Technology for good, but also can be used for bad. I mean, that's the reality.
It is a true new front for the cyber. It's true. It's real. I mean, Microsoft just got hacked, with thousands, solar wind, and the types or the reason varies, but the end result is the same. It is a compromise for what we're trying to do. And we're in the free world. I'm a patent holder. I love what I do. That's what some people are after. They just want to take your information for granted, unfortunately. And in the US, it's been decades of hard work to actually produce something so creative. And a lot of people like it and envy it. Instead of replicating that process, they just go take the results of that. And I think it's unfair. We should just need to be safe.
So I have a forward-facing kind of question for you, and we kind of like to look ahead, and so in your opinion, what would you say the future of wireless modules and security and connectivity? What could this look like that we're not even considering yet?
I mean, in the future, we will basically have no cords whatsoever. Everything will be wireless. And I'm talking about everything. Your fridge, your everything will be connected. This is real. I mean, we have the capability of doing that. But again, the key for that, it's today's security. The reason why you don't see millions of cars yet that are 100% connected with, autonomous driving is security. And it's been proven. Tesla was hacked, and unfortunately, and a lot of these things. So until we get that our mind wrapped around that, well, it's difficult to let go. Today we're at that point where we're trying to let go. We're doing as much as we can, but it's just to open up, almost blindly in a way, and just have everything. We have not get that comfort level yet, and I'm not talking about from consumer adoption. I'm talking about from technology too, because we need that level of security to be safe.
So with security comes the technology changes is really what we're saying. As we're able to become more secure, we're going to see these things be more commonplace.
100%. And like what I said, there is no silver bullet for anything with time scale. So we just have to be on the edge. We just need to constantly, improve. Whatever we come up with computing, we have to come up with security. And this is part of the game today. You cannot just make one fast computer anymore without thinking about how to secure that fast computer.
Security is key. This is going to be the key.
It is 100%. And it's just like our lives. You go home, you have to secure your home, you have to lock it.
Right.
I mean, this is not a new concept that, we didn't live. It's just having at the cyber level is really the new arena. And it's as real as it gets. This is 100% there.
I mean, and engineers they're thinking about this, right? As they're designing, I mean, as they're innovating and creating prototypes, right? They're in it, right?
Well, yes and no. So this is
Yeah.
really this is a very good point.
We hope we would like for that to happen.
I believe there is. I believe there is, but I really believe this has to be adapted at the national level. When it comes to this type of front, commercial, we could do so much on our own, and we could be working, I would say, different hands, which is really being very creative. But this, I believe, has to go at the highest level, and it has to be a national guidance and national pipe. Because I've had some friends in the industry, even with solar wind get hacked and all of that. I asked them some simple questions about blockchain and what have you, and they said, "Oh, it's not implemented." It's like I was surprised. Like, how could they, be at this level not implementing some, security measures? Maybe they will be, maybe and all of that. But what I'm saying is, we have to realize this at the highest level and really pipe it down of a process, measures, plan, a decisive plan, and comes obviously funding. The government, I believe, has to step in to help out. The part of the national budget for the army and and all of that, it's massive. I didn't see much about the security part, in the recent budgets, or not as much as I would like to see. This has to be at the highest level, to be addressed.
Well, Ahmad, this was very insightful, and I think very important for engineers to really start thinking about. So we thank you for sharing this. But in the meantime, can you let everybody know where they can learn more about Global Telecom and the work that you're doing?
Sure. I mean, Global Telecom, we're in the web, globe-tel.com. We have, a lot of news. We're on Twitter and LinkedIn. We're quite active to share what we have and what we know to a lot of people, and they could reach out to me. I'm Malkawi at globe-tel.com. I'll be happy to. I love to interact, especially with engineers and with our community. And like I said, I am by education trade and engineer, and I'm glad that actually whatever I'm doing, makes us some money. Otherwise, I'd be having a hard time. So that's about the only thing that I do. I played tennis in the past, but I wasn't that great to actually make money. So I'm happy what I'm at. Let's put it this way.
Well, I don't know, with 6 siblings that are all engineers, or 5 of them ahead of you, I don't know if you had much of a choice.
No choice. I'm telling you, the bar was so high, and all of that is like, it's basically which engineering you want to pick. Basically, it's like, you want to be mechanical, civil, electrical. So I picked electrical, and electronics. So it was great.
I can imagine the dinner table conversations, like everyone's like,
yeah, you will. A lot of my friends respect, all stuff when you go with your siblings. I mean, it's just war, man.
that's awesome.
Doesn't matter what you've achieved. There is always somebody who's done something more. But it's fun. We have a great relationship. We respect each other. It's great. So.
Well, I've got to say that the one thing that I love about the engineers that we speak to on the show is that everybody wants to have conversations with other engineers, and they're always so willing. They want to have those discussions, and that's really a very nice thing about the engineering community. Something I admire. I don't see a lot in other industries.
It's for us is really brightening. Let's put it this way. When we speak with someone who's who knows what they're doing and all that stuff, it's really enlightening and brightening. You really know you're getting something more, and it's exciting. There is always even one sentence could be something that, oh, I didn't know this before. It's exciting. And this is, I think, the idea of knowledge. It's really how much knowledge. I hope my brain keeps up with me, but I just whether it's NASA, whether it's going to Mars, whether it's going to the moon, whether it's the new telescopes that's going to the universe, how can we use some of the stuff that we have today to actually enhance that? I mean, all of that, and the more you read, the more all of these ideas come through. They like almost like a puzzle. One piece at a time, and later it's like, oh, okay, now I could do this with this. So it's always exciting. It's
okay,
really
so
exciting.
You mentioned Mars. You mentioned
Go ahead,
Mars.
Brian. Go ahead.
We asked this a lot. When do you think we're gonna get to Mars?
Oh,
get
boy.
on Mars. What's your prediction?
That's so funny. Humans to be on Mars. I would say probably the way Elon Musk is going, it's probably in 10 years. It seems that he's very determined to put somebody out there. 10 years ago, I probably would have been. I would love to go, but now it is like, it's all scary for me, So, but I would say in the next 10 years, by 2030, 2031,
nice.
I have a feeling somebody will be probably on Mars.
All right, Brian's racking up his predictions from all of our wonderful guests.
He's trying to see who's going to win.
I think you're right. Some people tell us like, around 35. I think you're right. I think it's going to be like 30, 31. I think it's going to be right at the turn. I'm with you on this. So that's my prediction.
And we'll find you in 10 years, and the winner gets a prize. That's what we'll start.
That's right. We will give you a prize. I don't know what it will be, but we'll give you a prize.
A day trip to Mars. I don't know. We'll come up with something.
I will look forward for that. But I think with the technology we're seeing, with the rockets, with the speed and all that, I could really see it coming to up, to that we could get there faster, a little faster, maybe, and have the resources, back and forth, whatever, just to be able to put it safe enough, at least, to send somebody out there. That's what I believe. Now, I don't know if they're going to go back soon, just like the moon. You went there for a few times. It's like, it's just a dead rock.
It's like,
we'll come back later. Exactly. So I don't know, but I believe, humans, as you could imagine, we just love challenges. This is just what makes us thrive and motivated. So,
thank you so much for joining us today.
Yeah, thanks so much. We appreciate it.
Same here, Brian and Nicole. Thank you so much for your time. I appreciate this. This is wonderful.